purpose of this video is to consolidate your ability to recognize circle theorems. And what I want you to do is work through the video. I'm going to try so that you don't have to pause it, but you may need to pause the video if you need more time. So what I want you to do is tell me what theorem is this. So most of this video, you don't really need to show me evidence that you've written something down, but you might need to make notes, or you might need to do some calculations. That's up to you to do those. So what theorem is shown here? Try not to use a reference guide now, because you've gone through them enough. You should be able to kind of, from memory, be able to pick up what these are. So this one is just going to be angles in a semicircle is 90 degrees. And that's good enough. You don't have to say triangle either, which is a bonus, I guess. Have a go at working this out, please. Okay, so from here, I may not do all the questions in detail, but I will go through the key parts here. So you know that if this is a triangle, well, that has to be 90. From that, you can actually work out this angle here, because if you treat it as one triangle, it's going to be 180, take away 48, take away 90. That gives you 42. Okay, so if you know that that's 42, well, this is also an isosceles, so that will have to be 42 as well. Okay, question 2, which theorem is shown here? Okay, you should have got this immediately. The angle at the center is twice the angle at the circumference. Here's an example of a question. This is almost too easy. You can probably, I'm not going to pause the video for this. You can just half it, so you get 64. Question 3, which theorem is this? Okay, so if you draw a line from there, you can see this is a segment, and they've even been highlighted, so they match. So angles in the same segment are equal. Here's an example of a question. It's a little bit trickier when it's just turned over or rotated, but actually it is not necessarily difficult though. So we can say if that's our segment here, well, that's 34, that's going to be 34. You can say angles opposite each other, vertically opposite angles are going to be the same, so that's 86. And then you have a triangle, angles in a triangle. So 180, take away 34, take away 86. That gives you 60 degrees. Okay, what theorem is this? All right, again, you could have probably picked this up quite quickly. Opposite angles in a cyclic quadrilateral add up to 180. So here's an example here. Now you've only been given 3 angles in a normal quadrilateral that you were given. If you're given 2 angles, you can't really work out the other 2, but because this is a cyclic quadrilateral, you know that these 2 add up to 180 and these 2 add up to 180. So we can do 180 minus 94, we get 86. 5, what theorem is this? Again, you can probably do it straight away without pausing the video. It's going to be the tangent meets a radii at 90 degrees, or radius. Here's an example here, work out angle x. So, okay, you should have had a go. You know this is 90, and then this is just a triangle. 180, take away 90, take away 52. You get 28. Question 6, what theorem is this? Okay, so you may have possibly struggled to articulate this one, but it is actually a simple theorem. So tangents meeting at a point are the same length. Here's an example of a question. Work out the value of x. Again, this is a bit too easy, I think. So you can just see x is going to be 6, because those are your tangents here. Okay. Just as a bonus piece of information, those also have to be 90 degrees. That's sometimes combined with angle at the center is twice the angle at circumference. So if you're told that this is 28 or something, you can then work out this angle, and then you can work out this angle. Okay, next question. What theorem is this? Okay, so you should have got this alternate segment theorem. This is the trickiest one to spot. Again, remember that when you're going along the tangent and up the stairs, that means this is the angle you want, the first angle, and then the last angle, they will match. Here is a simple question on alternate segment theorems. They can get much trickier to spot. So here you can see you're going along the tangent. That's your first angle you come across, and up the stairs. So that means that x has to be 54. Question 8, work out the value of x. State which theorem you're using. Okay, so you should have had a go. Now, you know that angle at the center is twice the angle at the circumference. Do not get these mixed around. When we say angle at the center, we mean this one, and angle at the circumference is this one here. So 82 times 2 gives you 164. And then we can work out x because it's angles around a point. So 360 take away 164 is 196 degrees. Question 9, work out the value of x, state the theorem. Okay, so having a go, you should have done it now. So this is 77 because it's vertically opposite angles. This is 43 because it's angles in the same segment. So these two have to match. And then from that, we can work out this angle here because it's angles on a straight line. So 77 plus what is 180? Well, I can do 180 minus 77. You get 103. And then you have a triangle. Angles in a triangle add up to 180. So 180, take away 103, take away 43 will give me x. 180, take away 103, take away 43 is 34. So notice the number of reasons I've used. Vertically opposite angles. I've used angles in the same segment, and I use angles in a triangle. Obviously, you cannot use shorthand like I've just done. Question 10. Okay, so you should have had a go now. We can say that this is going to be 360 take away 140 because it's angles around a point, so that's 220. And then this is going to be half because it's angle at the center is twice the angle at the circumference, so that's going to be 110. Right, so that is, I think that's everything for this video. The next video I'm going to show you how to lay your work out, or I might do another mini whiteboard video. I haven't decided the order I'm going to post these in, so see you in the next video.